So with this equation of motion, we'll study about object under free fall. Now say this is point A and this is ground at B, and the distance here is h. When a ball or say any object is dropped from A to B, initial velocity you have to consider as 0, because I will be just dropping the ball. So initial velocity is 0. The final velocity is something we need to find out. Time, say it takes t time to cover distance h. Now the ball is falling under the action of gravity. Ball is falling under the action of gravity. When it comes down, you will observe when you throw a ball from down, the speed is going to increase. So by how much it will increase? It will accelerate by g, where g is nothing but acceleration due to gravity. Now at any point, say at this point or this point, if you want to study what is the velocity, the final velocity. Now I just consider point A and point B. At B, you have to find out the final velocity. So final velocity, to find out the final velocity, V equals to u plus at. This is the first equation of motion. U is 0 since I have just dropped the ball. A is your g, acceleration due to gravity, and t is the time which it takes to hit here. So this is the final velocity. Now at this point, after time t1, you need to find out what is the distance after time t1. What is the distance it has traveled from 0 to this, or if you are interested to find out from here to here, anything. So for that, what you can do is s equals to u, because you don't know the final velocity, you know the initial velocity and the time. So half at square. So you should be very wise in choosing three equations: v square equal to u square this, and v equals to u plus at, and s equals to ut plus half at square. You should be very wise which equation I need to choose. In the first one, I had to find out the final velocity when I know u and acceleration. Also I know t. Now if you try to use this one, if you know h, you can use this. If you don't know h, you can use this. So it's just based on whatever inputs you know and whatever you have to find out, you need to choose this equation. So s equals to ut plus half at square. To find out this, since I don't know the velocity, only two equations to find out s is this second one and the third one. But in the second one I don't know what is v. In the third one I have all the values. So I'll use s equals to ut plus half at square. U is 0, so this goes half. A is your g and t square. So this is the relation to find out s. So for any given time t, it is going to travel s equals to half gt square. So this is how you solve the relation or the equations for object under free fall. So I'll be taking one question from object under free fall. The question says, from a top of tower 100 meter in height, so there is a tower, say tower is A, B, which is 100 meters. A ball is dropped, so from here a ball is dropped, and at the same time another ball is projected upwards from ground, say B is ground. At the same time there is another ball, say this ball is small a and this is small b. Same time a ball is projected vertically upwards with a velocity of u equals to 25 meters per second. Find when will the two balls meet. Now, first what you have to understand is, when a ball is dropped from top, u is equal to 0. Well, I can just leave it. But when I am throwing it upwards, I need some velocity to throw the ball. And ultimately when it reaches certain height, it is going to be 0. So here final velocity is going to be 0, and when I am throwing it down, your initial velocity is 0. Acceleration when I am throwing it from top is capital G or small g, positive, since the acceleration is going to increase. When I am throwing upwards, your velocity is going to decrease. Obviously, otherwise ball will keep going. So your velocity is going to decrease. So acceleration is minus g. Both are under the action of gravity. What we are supposed to find out is at what point will the ball meet. Say they meet here. I'll just take a reference point. Say they meet here. Now since they meet and they are thrown at the same time, both are going to take time t to reach at this particular point. Say this is point C. So we are interested to find point C. Now the constant thing is t. So time taken by ball A to reach C is going to be equal to time taken by ball B to reach same point C. So we need to utilize time. Since time is a reference, it's going to be same. Say as I'll just write down the three equation. V equals to u plus at, s equals to ut plus half at square, and v square minus u square equals to 2as. Time taken to reach C. Now say so time A to reach C is going to be time B to reach C. Also if you see, if this travels distance x, other one is going to travel 100 minus x. So just use s equals to ut plus half at square in both the conditions. So SA is nothing but ut, so ut for A plus half of at square for A. This is suffix A. So u is 0 for ball A. G is nothing but A is nothing but G. So G t square. So this is S of A. Let's just take this as equation 1. So the same equation I'll use for the second ball B. So S equals to U. U is nothing but 25. It is going to travel T ut plus half. A is nothing but minus G t square. And this is going to travel SA, I can say it is x, SB is nothing but 100 minus x. So 100 minus x can be half gt square equals to 25t minus half gt square. So half gt square goes, 100 equals to 25t, t equals to 4 seconds. So we found out what is time t, but what we are interested to find out is x and 100 minus x. So you just put it in this equation, half of gt square, g is, I'll take 10 meter per second square, it is actually 9.8 meter per second square, I'll take 10 into t square, t is 4, so 4 4s are 16. So it is 80 meters. So x is going to travel 80 meters, while this is going to be 20 meters. So your answer can be 20 meters from the ground or 80 meters from top of the tower. These two balls are going to meet. So equation, it's very simple if you understand the concept. It's very simple question.